talking to my. There we go. Wow. As I was whining about talking to myself. Okay. So we started with a couple fun slides here. Everybody recognizes this brand, Firefox. This is one you guys will come to recognize. I'm also wearing it on my shirt. So this is part of the marketplace we're launching with the Firefox OS. So we just threw them up front on our slide. So today we're going to talk about scaling websites, some of the lessons we've learned at Mozilla. I'll let you start.
I'm Brandon Burton. I'm actually based out of LA and part of the WebOps team.
And I'm Chris Turra. I'm based in Vancouver, Canada, also in the WebOps team. Brandon and I work together. So many of you guys probably know, some of you might not. Mozilla is not just Firefox. We have a lot of other things. And we have a lot of web properties. So some of the things that are on the slides in front of you are web properties that we operate. So Mozilla.org, obviously. Through Mozilla.org, we do Firefox downloads, which is a massive site. Input.mozilla.org is where you can leave real-time feedback, whether, if Firefox did something you don't like, you have a little sad face and a message about how much it sucked, or maybe how great it really was. We really appreciate openness and honesty about that stuff, so don't feel like you are going to offend us. Crash stats. So this is a really massive site that we operate. It takes any time your Firefox instance crashes and you choose to submit crash reports to us, it takes all that information, we store it, we do analytics on it. It allows us to either improve processes or just realize that something's really broken in a release and get a quick fix out for it. And then the support.mozilla.org is kind of our user support forums. We don't obviously have a direct support phone line, but because we're open, it's kind of the community portal to that. And we have hundreds more. It's about 450 web properties that we manage in our group. So today our talk is gonna talk through a couple of things that we do. We're gonna go over the architecture, how we use load balancers, databases, asynchronous jobs, caching, self-service, platform as a service, cloud, some of the stuff we're doing in the future. So our overall architecture for most of our web properties is identical. We have clusters of everything in multiple data centers. Every cluster has at least one admin node, and then it has a bunch of web nodes depending on how large the web properties are. They have, 3, 4, maybe hundreds. Database nodes, because almost everything we have has database behind it, and some clusters are shared. And we'll go into that a little bit. So this is kind of what it looks like. Every site kind of has more numbers here and there, but generally that's what the stack looks like. We have a load balancer in front of everything. Every site has at least a dev instance, a stage instance, and a production instance. And then behind those are clusters of databases, storage, Celery, Redis, other things, and at least one admin node. I don't know. Can I? Yeah, that's about as good as it's going to scale for you. I'll give you guys a couple seconds to have a look. But the purpose of the slide was really just to kind of give you an overview of some of the stuff we do. We will be talking to each of these things kind of individually through our talk. And feel free to take notes here if you're like, that seems really weird, or why are you doing that? We will have a Q&A session at the end, so feel free to ask us anything. We are an open source organization, so we'll tell you probably anything you want to know, hopefully. Okay, so Brandon.
So obviously a core component of any more than any one or two node service is going to have load balancing. We use a load balancer product. It's now owned by Riverbed, and they kind of rebranded it Stingray, but it was a Zeus technology, so we still tend to refer to it as Zeus internally. It is a software solution that you license. We typically run it on Red Hat 6. We use HP DL360 1 and 2U chassis for the load balancing, and Miracom 10 gig network cards. Typically, we have 2 clusters in each data center. A front-end cluster, which is like HTTP, HTTPS, public-facing services are on that. That is where we do things like terminate SSL. It does caching as well, so kind of like Varnish or Squid as a reverse proxy cache. It's one of the built-in features, so we use it for all of that. We also use it, we have what we call an internal cluster. It's like a back-end cluster. So we put it in front of MySQL, put it in front of Memcache, Elasticsearch, Hadoop, in front of kind of any TCP service, and we use that for failover as well as like round robin, in case of like read slaves. Fairly performant in the hardware stack. We went through a number of 10 gigabit network card models early last year because for one of our sites, version check, we call it VAMO. It's versioncheck.addons.mozilla.org. Every Firefox instance that is running hits it once every 24 hours to, is there a new Firefox? Is there new extensions, plugins, all those things? And so we have over 500 million active Firefox users. That creates a lot of traffic. We're pushing over 200,000 packets per second on an SSL-enabled service. So we went through a number of things. We ended up landing on these Miracom cards because what they do is they're bonded, but they bond in the firmware. So they present a single Ethernet instant or interface to Linux. Because what we found is that trying to push high PPS and do bonding in the Linux kernel it wasn't really scaling. It wasn't scaling to multi-core. And so with this, we're able to reliably serve over 200,000 packets per second for that, in addition to the other hundreds of thousands of packets that our other sites push.
So we have a couple of these things called databases, and I can actually see Sherry in the back counting right now. She's one of our DBAs. So you can wave to Sherry. She's losing count. So probably like many of you guys that have MySQL in production, we're running MySQL multi-master, so each of our data centers has masters and slaves. But what we choose to do is we choose to only have one of our multi-masters as the active write. This kind of allows a little bit more sanity for, I'm sure each of you guys, if you've used MySQL, would understand. And for read, so a lot of the stuff that we do is, I would say, more read intensive than write intensive. So we also set up read slaves. This little configuration snippet that you see on the screen, this is actually part of our Django, one of our Django apps. Almost all of our apps are written in Django. We have our own, down in the back. We have That's okay. It's okay. We actually have our own kind of version of Django that we maintain called Play-Doh. It's a framework that's kind of out of the box. We maintain out of the box. Our developers can just add a couple things onto it, and it's the Mozilla Django setup. This is how we do our slave configurations, and the password there is not real. If anybody can tell me what it says in LeetSpeak, you win some. Yeah, he thinks this is real. It's funny, actually. Brandon gave a similar talk to this at LA DevOps Days, and people actually thought that was a real password, but it's not. And for the hardware below, our database servers, as you can imagine, they're pretty active. So we've got some pretty decent SSDs underneath them. We got them on HP blades. We've got Fusion IO cards, which is like really performant disks, and then we also do SSDs. And we're very, very blessed to have 3 awesome DBAs. Sherry is here, and she's one of our DBAs. We do a lot of really great things by having great DBAs. Obviously, managing the databases is a huge asset. But we can also go into other things that are really great, like query optimization. You can have queries reviewed by somebody that's really, really good at queries, like a code review, right? And that's something that kind of becomes an asset when you're starting to push through the kind of load that some of our websites share.
All right, so asynchronous jobs, and obviously the term asynchronous can mean a lot of things, but in this case, we are kind of referring to it as not blocking our web application. So taking things that need to be done as part of the workflow of a web app and putting it to the side of the client interaction. So we use a tool called Celery, which is a Python. It's a framework. It is both a client and a server. So on the client side, you have a client that does an API where you define tasks and jobs. And on the server side, you're running a service that has like a master process and then a set of workers, and those workers will execute your jobs. So it is written in Python. We use it with Django. We use Supervisor D to manage the server-side process. And we use RabbitMQ as the message queue between the web app Celery client and the Celery service. Celery can actually use a number of brokers, even MySQL, Redis, AMQP, a couple other things, Beanstalk D, I believe. And so, but we use RabbitMQ. So we have a production cluster of RabbitMQ per data center that we run. We have a Puppet module that lets us scale these horizontally. So typically we'll have at least 2 nodes in the data center. That's where we're at right now, is 2 physical nodes with Intel processors, SSDs, and queues are durable to disk, but we do not use mirrored queues for most things. So messages go through RabbitMQ for Celery, amongst other things. And the idea with with RabbitMQ and with Celery is that we take anything that can be done, not in the direct path of the website and push it out. So say someone uploads an image for a profile, right? You want to make a thumbnail, maybe you resize that. That will be passed off to Celery over RabbitMQ and then processed by the Celery box, the Celery cluster. And so what that will do, right, is the file is uploaded, it's written in the file system, a message is put onto RabbitMQ that contains, metadata. It says, okay, here's information about the file, here's the file path that is available to both of the web servers and the Celery cluster. And then, here's the code to run, right, the functions or whatever to resize that to make a thumbnail. Or send an email, like you sign up and you have to validate your email address. Any kind of a task like that, we put off to the side, and then they're processed as best you can get to it. Also things like you're using Elasticsearch, right? Every now and then you want to rebuild your total indexes. We have cron jobs that kick off Celery processes to do like a reindex, or maybe it's going to go every 24 hours and run through and send out a bunch of emails, things like that. We use Celery as the way we run all those.
Caching. So we use pretty much vanilla Memcache on all of our nodes. Actually, Brandon, do you want to talk to this? I think you did in our last slide.
Sure. Sorry. Yeah. So Memcache. Obviously, disk is slow, RAM is fast. Right. Put things in memory that are volatile, that can be ephemeral. So we use it. Sessions is a very common thing. All our Django apps, MediaWiki, WordPress, all our sites, they all use it for sessions. We even put things like RSS feeds, right? Puts it in Memcache, have a cron job, regenerates it every hour, 24 hours, whatever. The idea is put everything into a Memcache store that is ephemeral. We don't care if it can be lost. We can rebuild it from data. If we were to lose a node. And typically what we do is we have 2 Memcache nodes in a load balancer. They're active passive. We don't really worry about warming up the other one. So if there's a failover, the cache is going to be cold and it's going to have to warm up. We don't try to optimize for that too much. Okay. All right. So Memcache databases is that's a very common thing. We have a plugin that one of our web dev guys maintain called Django Cache Machine. And what it is it hooks into the Django Object Manager. And so right there's a query, something that the data lives in the database as the sort of source of truth, or I'm going to make an object to fetch it. It will look in a cache first. That cache can be a number of different caches that Django supports, but we use Memcache. So what that does is, there's a query for data. It looks in the cache first. If it doesn't find it in the cache, it reaches out to the data store, which is MySQL in our case, returns it to the client, as well as it populates the cache. So it's sort of like a read through, and then it populates it. And so that then insulates our database for most commonly accessed data, and we're able to serve it out of RAM. So local HTTP caching. As I mentioned, we use Zeus for our load balancers and for reverse proxy caching. If you're not familiar with the idea of a reverse proxy cache, the idea is that you have a web server, Apache Nginx, and it's going to be running some kind of dynamic code. Mod PHP is probably something a lot of you are familiar with. Mod WSGI, stuff you might be running like Thin or Unicorn for Ruby, or Mongrel, G-Unicorn or Twisted or something for the dynamic container. But you've got a web server that's doing your, proxying to your dynamic application container as well as serving your static files. But even then, you can actually serve it faster if you serve out of memory for something that's optimized for that. And this process is referred to as a reverse proxy. So you have a service that sits in front of your web server, accepts traffic through to it for assets that you tell it it can cache. JavaScript, CSS, images, MP3s, typically binary files is where people start with this, or plain text files. It's going to cache it in memory and then serve it out of cache if it has it. So Varnish, I think, is the most common one probably people are using. Squid can be a reverse proxy as well. The Wikimedia guys for Wikipedia and things used it for a long time. I believe they still do. But in our case, our Zeus load balancers that we already have this function, and so that's what we use that for. Now, that is kind of what I refer to as local cache, but typically that's on the edge of your network. So, but you can go beyond that. You can go global HTTP caching, right? CDN, Content Delivery Network. Edgecast, right? One of our sponsors, thank you, is one of them. We use them. So we have 450, 500 million active Firefox users. We do a release every 6 weeks. So that means a lot of downloads are done. We use Akamai and Edgecast. We balance the traffic between them using Dynect. Dynect has a DNS-based sort of product where it does performance measurements of the nodes that you tell it are your backends effectively. And it will send your traffic through based on DNS lookups to the nearest IP that it sees as performant. So we use this to give our users the fastest pop in their region based on either Akamai or Edgecast. So we're sort of performance-based load balancing in front of CDNs to deliver the best experience. We actually, for a long time, and some of you probably remember, we had a big Mir network. That was, that's very common open source, and we used that for a long time. But CDNs have come into major playing since the time of Mozilla and Mir networks, and so our release engineering team and IT spent a lot of time looking at this, and it was a big change, but we did a lot of tests. We did A/B testing, and found that through CDNs we were able to improve the uptake rate of Firefox downloads and updates because it just improved the download experience. Because often what would happen with GeoIP lookups, is you might get a bad mirror, get a slow mirror, and all of a sudden it's like 10 minutes to download. A lot of people just say, hey, I'll go get Chrome, or I'll stay with IE, or I'm just not going to update. And so we found that moving to CDNs dramatically improved a lot of uptake for downloads and updates. And so we switched to that is the main source of downloads now, and we're sort of doing these things to do the best that we can with Akamai, Edgecast. We have other CDN vendors that we talk to and we look at, and what we basically want to do is give anyone in the world the best download experience, the fastest one that they can.
So on to these. The other day I actually took some of these snapshots out of our Akamai dashboard, and I wanted to share them with you guys. This represents hits per second when over 3 days, January 10th to 13th, when we released Firefox 18. So you can see the initial kind of spike. We usually kind of introduce the release in the morning and then kind of hold it back just to see what kind of uptake there is, if there's any increases in our crash stats like I was talking to you guys about before, and just general feedback from users. If everything looks good, then we kind of ramp things back up. So you'll see the initial spike there of hits per second kind of goes back down to a lower number. Things were looking great. We send it up again. So this 3-day period represented 5.5 billion hits, and our peak hits per second was about 59,000 hits per second. Sure, just to Akamai. Edgecast would also have had 35% of these numbers. So what does that represent in bandwidth? So you'll see the graph looks pretty much the same, but in 3 days the total volume of downloads was 2.1 petabytes, and peak traffic at about 163 gigabits per second. So it's a big amount of data and a lot of hits per second, and it's actually really fun looking at these graphs. So I thought I'd share them with you guys. I would have actually done the Firefox 19 release, which just came out the other day, but we're kind of still in the trailing edge of. Every release kind of has this look, and you'll see near the end the tail kind of goes down, kind of goes up a little bit with some of the later adopters on updates and stuff. So we're kind of in that tail right now, so it didn't give me as clear a picture, but about the same numbers for this week's release. All right, so how do we scale out our services or our servers? Config management, you guys heard that a bunch today if you've been in this room. probably don't need to hear about being idiots if you don't use it, if you guys are here for the keynote. But you really, really, really should be using it if you're not, so reevaluate that. We choose to use Puppet, but there are other options out there. Chef, CF Engine, I'm not going to miss it. And there are, I'm sure, are others, but those are kind of the three big players. Like I said, we choose Puppet. Oh, and Brandon actually gave a Puppet talk for those of you that were there just before this. And we use disposable webheads. So the idea that we've got is that we want to be able to put out as many of these webheads as we get requests coming or traffic coming, and they need to be disposable. We need to be able to have them come online, go offline, doesn't matter. They need to be in lots of different locations. So the goal is nothing can be shared on them. They just need to be a webhead that gets some stuff. We push data to these. So I'll skip into how they're built out. So if we want to stand up a new webhead, we use C-micro Xeons for most of our webheads, which I'm going to go into in another slide. Basically, the gist of it is it's a very dense amount of hardware. We don't use virtualization for a lot of our webheads and stuff like that. We use it kind of on the admin side of it. But we can quickly stand up a new machine, a new C-micro instance, quickly puppetize it. It gets kind of its things and is able to serve requests. We get code to it by actually doing git pushes from our admin nodes. So our admin nodes have kind of what the www root is going to look like and all that kind of stuff. And as things come up, that data will be pushed to it or pulled, depending. And nothing on those webheads is to be shared. So any shared services like style sheets, images, JavaScript, other things, we store in NetApp NFS mounts. We're also looking at other things for as we're moving more services to other places like Amazon EC2 and Rackspace, and there's lots of things. We're looking at moving out some of our storage that would historically been on NFS to places like Amazon S3. So this is what the C-micro chassis look like in one of our data centers. In this rack, you'll see 3 of them. C-micro is really quite awesome and gave us the Firefox painted one for Christmas. I was in our Mountain View office when it arrived, and it was really, really cool. It's really nicely done. So that was a gift to us from AMD C-micro for Christmas. But what this shows is kind of the density we're able to achieve. So every one of these machines has about 192 physical hosts in it. And these hosts are running Xeon Intel processors, so like they're 8 cores, like massive amounts of memory, and we can get 192 of them in 45U rack, which would on other hardware give us about 64 hosts, sorry. And it gives us the opportunity to save about 75% of our space and power footprint on each of our racks, which, given the number of racks we have, pretty significant. It also makes managing this stuff really easy. Like, typically managing hardware isn't really the easiest thing, right? You need knock monkeys or something to kind of be doing this stuff. Once these C-micro Xeons are in place, we can manage them like a switch interface. So it's kind of like Cisco IOSE, where you log into it, you can do a bunch of stuff like a switch. Your machines are up and going. You can do it all remotely.
So the future, we've kind of told you a lot of where we're at today in terms of scaling, and obviously, but we can keep improving. So one of the things that we're working on, and because scaling, right? There's certainly scaling hardware, but there's also scaling people. So DevOps culture is something that we are obviously talking about, looking at how the kind of relationship that IT has with web dev and WebOps specifically has with web dev is very much what you might call a DevOps culture, though it hasn't. A lot of it's developed organically. But some of the things that we have that speak to that are we typically run we call blameless postmortems, blameless postmortems. Etsy, right, is very kind of has been in the news talking about this idea. John Allspaw, their Business Insider, I think, even wrote an article about it. But the idea, they're like, okay, something goes wrong, so we figure out what it was, why did it happen, what do we learn from that? No one is blamed. Things happen. And, we figure out, all right, what do we do for remediation, better monitoring? If it happens again, then maybe we start, looking at, specific things. But the idea is, in general, things go wrong. Blaming people, trying to assign blame just wastes time. We're all invested in the same mission. In some ways, Mozilla, it's an open source project. So there's a mission there, right? And there's a mission, open source, open web. And in general, the people that come to work at Mozilla, part of it is the mission. We're all invested in that. So developers want websites to work. They aren't throwing code over the wall because they care as much about the users who are using the website as the op people. It's a shared goal of delivering the value through the website to the community. Continuous improvement, right? There's very much a culture of just constantly trying to improve things. From the web app side, I'll talk a little bit about some of the things that we're doing to improve that, and just hiring good people. That's just kind of part of the culture. You hire good people, they want to do awesome work, they work together well, and it goes well. So self-service, that's kind of the mantra that WebOps has had for the last year. Our team grew last year from 2 people to 5 people to 7 people. And so, very quickly we had a lot of people, and we looked at, all right, we have people, what are we going to do? And so self-service, the goal kind of is, the idea is we become platform engineers. We build tools that are self-service enabled to let our developers do what they need to do, and we focus on building the tools and platforms that are going to help them. Continuous deployment is, a real common, right, DevOps kind of a thing. So what that means for us is, we give the developers tools where they can, log into a web interface and one button click deploy their code. The scripts that deploy the code are in their code repositories. We share the same GitHub repo for maintaining that. They're able to, okay, I want to swap out my minification tool because I found a better one. They can go and do that. They ship the code in their repo, and they just change that. Django Waffle is a plugin that some of our web devs maintain. It is for what we call dark launching or feature flags. You might have heard John Osbog talk about this at Flickr and Etsy. Other places, Facebook, a lot of places do this, right? The idea is that you put code and you actually deploy it, but the end user doesn't see it yet. You're able to, through a flag, sort of have it, turn it on or off to the end user dynamically without potentially even having to push again because of this. So we use this in production on a number of sites. Sumo, which is support.mozilla.org, AMO, which is add-ons, our input site, MDN, which is the developer wiki. Basically, the sort of high-level view of how Django Waffle and this process works in general is that there's an active flag that says, should a certain feature be on? And it can check a number of things. It can look at cookies. For example, like you say, okay, I want 10% of my user base to see a feature. You can put that into their cookie. So they always, once they've become sort of selected to get that feature live, that cookie always looks for them. Then it can look at, certain roles, right? In Django, there are roles based on users from MySQL. So super users, groups, and then what we call a dice roll, which is sort of randomized A/B testing. It's not just it's A/B. It could be like ABC, ABCD. Like it can, choose from, 1 out of 5, 1 out of 10 users to get a feature and see what it does. So self-service continuous deployment. The tool that we've built is called Chief. Basically, this is what users get. They get a button. There's a couple of forms. You put in who you are. You put in a password. We just have shared passwords so that there's just that psychological barrier, so that you just don't go and click. You've got to think, all right, I have the password. I got to put that in. And then there's a field for it's the Git reference. It's like what branch am I pushing or a SHA-1 or whatever. And then they click the button and it goes and just shows them the output. So yeah, go ahead.
Can I quickly add a point on this? The other way that we've enabled our developers, especially when they're pushing code into production, to see, because we allow our developers to push code in production, because why not? No, they're outstanding. So seriously, why not? But the challenge that gave us is how do we give them the information of what's happening, especially if it's failed, right? Like if a deploy fails, I don't need them to light me up an IRC or whatever unless I'm absolutely necessary. So as part of Chief, we've also built an IRC bot that gives them real-time logs into an IRC channel so they can see what's going on while they're doing their pushes. And if it fails, they see exactly why it failed. Sometimes we need to get involved, but it's not like, IT ops guys, something broke, and we might not know that they're solve the problem for them, but they can come to us and say, hey, this is what's going on. Can you look at it with us? We can powwow, get it done really fast. So that's a really key way of why this has been successful.
Another, yeah.
It's part of Chief. Yeah.
Yeah. It's a separate bot, but we wire it into Chief. They communicate over Redis. And so, yeah, it does, as the steps in the script that Chief is running complete, it's giving that output. But yeah, that's a very good point, is that they don't even have to watch the web interface. It can be in their project IRC channel. Typically, there's teams around projects, and they have their own IRC channels. So another thing, a very common tool is Jenkins. Our Jenkins infrastructure is self-service. It requires an LDAP login, but beyond that, any developer is able to go and make a job. If they need a library, in the past they've sort of asked us, and we've added a Puppet to the host, but we're actually trying to move into Vagrant-based, and we're also looking at maybe LXC-based containers, so that the developer can ship a Puppet manifest or even just a shell script, whatever. But their Jenkins job can be in a self-contained environment, so they don't even need to talk to us about I need something in the build environment. But yeah, and some of our sites, Socorro, which is the code name for Crash Stats, actually they use Jenkins to build the artifact that they deploy with, which is a tarball. Jenkins stage site automatically deploys from a tarball. The Jenkins job, if the build completes, puts a tarball on the system, and there's a URL that's a consistent URL that's like last known good build artifact, and there's a cron job that runs on the admin node for that cluster, runs every so often, and if the if that build number has changed from the URL, it pulls it down, deploys it, does the whole deploy process. So another self-service thing is Graphite. Oh, sorry. Right. So so generally the approach that, from what I understand, the developers take is they sort of do that on their own. Like, even with the pushes, they construct migrations that are non-destructive. You make your migrations, like if you're adding a field, you do it in such a way that old code doesn't notice. So that's the approach that they take. Usually, every now and then, someone will be like, oh, dev is broken because its migration is complaining because I need you to drop a table. But that's like maybe a 1% error rate in that approach.
And the key to remember with that as well is we don't just give them one environment. So our developers have access to a development environment, a stage environment, and a production environment. So after their code has made it through dev, which is a little bit more loose, our stage environment is a mirror of production. So if their tests deploy through, or if they deploy through stage and their tests all pass, there's no reason why it shouldn't in production. So by the time things get to production, it happens, but it's extremely rare that something's gone wrong or different than what we saw on stage.
So another self-service thing we're looking at, Graphite, right? Metrics. We use statsd plus Graphite, and developers like it. They just, they are able to look in the wiki and see, for my data, for the data center my app is in, what's the statsd host that I use? It goes into the Graphite cluster. So they're able to self-service metrics. They don't have to talk to us about that. They're able to, get what they need. Logstash. So Logstash is something we are currently implementing. It's not in production right now, but we're building a large cluster. We're actually dedicating a C micro chassis to all of the things that go into Logstash. If you're not familiar with Logstash, it's sort of a Splunk-like toolkit. There is, various agents that you can run, various inputs that it can accept that go into an indexer that writes the data to Elasticsearch, and you're able to access it through a web interface called Kibana that talks directly to Elasticsearch. So, you combine a couple things and you have a very much kind of a Splunk-like experience. So our goal with this is to get every log, every bit of data, log file that we want into this, and we have it, developers have it, they're able to, a lot of our developers have read-only SSH access to all the environments, and so, they can log in and tail a log file, but if you have, 12 web servers in production, that can get to be a little old. So this will replace that. It'll let them, go and do their queries and get their data. And so we are building a C microcluster that is going to run this. It's got a mix of SSD and SATA disks for Elasticsearch, so we'll do some tiered storage, hot indexes, and then, redundant Redis for the broker, redundant indexers, redundant agents, and yeah, so but the idea is self-service access to logs. So Sentry is an exception tracking service. You might have heard of like Exceptional.io or Hoptoad, or there's a lot of hosted ones. Sentry is available as a hosted service, but it's developed as an open source Django application as well. And so we have built a Sentry setup in both of our data centers, our main data centers. And what Sentry is it's a listener service and then a web service, or a web interface service. So what it does is if your application hits any kind of an error or an exception, you're able to fire off a UDP or an HTTP event with all of that data. So kind of like how with StatsD, right, you fire off metrics, this lets you fire off exceptions into a service. And then it takes them and collects them, puts them into MySQL, takes that data and indexes it across all the fields. And so what you're able to do then is go and log into this interface and see exceptions and search across them and see metrics. And so, in some ways it does a little bit of what Graphite does and a little bit of what Logstash can do, but it's very specialized to application exceptions. And it's a Django project. It's very friendly to Django. We're mostly a Django shop. So it makes sense to have this as a service. We have it in production. Developers are already using it. And again, it's a self-service. We've given various team leads and managers admin privileges. So then they're able to go and sort of self-manage adding their team members to their teams to see the applications.
What would be a very common exception that is tracked on the thing?
I don't know, to be honest. It's the developers kind of do that. We don't really often have to look at that.
And that, I think that speaks to what we were saying earlier is, our goal is to be platform engineers. We don't want to have to be we don't want people to have to come to us to solve their problems. We want to help facilitate that. If they need extra expertise in something or just don't quite get it, we're happy to step up and give that hand. But the goal here is that they can do it themselves.
So what's common? Sure. So the question, wrong way. The question was, what was a common exception that we might see? And that's going to vary by site. Stuff I've seen is maybe a vendor module didn't get updated, a library is missing, or bad URL in an API. There's various things, or file permissions. They thought a directory was writable by Apache, but it's not. So those are things that we've seen, but we're not really in a place anymore where we have to watch that. Before Sentry, before this stuff, the way it was is every exception generated an email. There was a distribution list in Zimbra with all the developers on it, so all the stuff went by email, and we were in a lot of those. But we wanted to get away from that, to where we don't have to look at it. Developers, they're the ones that have the context of the code, and we have so many sites that our role isn't to sort of be in them in that way. It's to build them platforms. And so a big part of our evolution as platform engineers is PaaS, platform as a service. Right? A lot of you are probably familiar with Heroku. Maybe some of you are familiar with Thought Cloud, Cloud Foundry, OpenShift. The general idea with platform as a service is that you have some code on your file system that you want to run. You want to deploy it. And the platform as a service is going to give you a command line client that you're able to interact with their service. You're able to say, okay, here's an app. It has a name. It needs some services. It needs a MySQL database. Maybe it needs a Redis or a Memcache. It needs a RabbitMQ broker. I'm going to create those, and I want you to tell me how I connect to them. Typically, the approach that they take is that their environment variables created, and you have code. You're ready to deploy it. You run, pass CLI space push, and that takes your code, bundles it up, pushes it up to the service, deploys it to an application container at a URL that works. Binds your services to it, gives you environment variables that you read in for config values, MySQL password, port, Memcache port, all those kinds of things. And Heroku, as I said, is a very common one. That's what it does. So, it's a very popular thing with developers. It's creeping into operations. So, you know, our developers are like, you know, hey, I love this thing. You know, I run a few commands. I have an environment. I'm working on a feature branch. I want, you know, a new environment. I want to play with something on a branch. You know, I want to be able to push. You know, I might only need it for half an hour. So, you know, them to come to us and say like, oh, can you give me a VM? You know, and you know, we got to do a bunch of puppet work. Like that's not productive. So we wanted to replicate that approach. So we started taking a look last year at some of the various offerings. You know, we experimented with various open source and hosted offerings and commercial offerings, sort of looking at, you know, the price versus build versus, you know, is it a product-focused project versus like, you know, it's an open source project and they're running a hosted version of it, but it's, you know, you're going to have to sort of like adopt their deployment style and their infrastructure style to take it. And what we found in the end was that Staccato, which is a product by ActiveState, it's built on open source Cloud Foundry, which is a VMware product, was what we needed. It's very turnkey. It's packaged as an appliance. They have support. They have devs working on it. They're continuously improving it, right? They do releases. The releases are tied to documentation. There's best practices. You know, they're running their own instance of it, so they have operations people working on it. And basically, you know, we licensed it from them. So, you know, it was sort of we needed a product. We were running a lot of services. We didn't necessarily have the headcount and the time to, you know, take something open source and then build on it. You know, certain, you know, other companies have done that, right? There's companies like AppFog that take Cloud Foundry and make their own PaaS offering off of it. Other companies have chosen to build their own PaaS. I know some people that were at Living Social, right? They built a Ruby PaaS. Basically, they took some of OpenStack and custom code and made a PaaS that was just for Ruby apps. In our case, you know, we support Django, we support PHP, we have Node.js, we have people using MySQL, Postgres, Redis, RabbitMQ, Memcache. So we wanted something that was a little more generic, and Staccato really sort of fit the bill. It's very generic, but also very turnkey. So we chose that, and we are in a sort of we're calling developer beta of it right now. Chris is kind of leading that right now.
Yeah, so right now we've got I'd say about a dozen active developers working on it across a bunch of projects in our developer beta. Our goal is to get this actually running into production at some point in the short term. We still need to get over a couple humps within just the way our applications run in systems and in our development environment. But the goal is to actually take a platform as a service all the way through to production, so that for especially our smaller sites, things that don't get upgraded or updated as often, developers can control the full end-to-end environments and code.
Cloud, right? To the cloud. We are looking at cloud for a couple of things, right? Dynamically scaling, right? We have two awesome data centers, great data center team, network team. They build it. That's our rock, kind of our foundation. But you know, cloud enables a lot of things, right? We can potentially burst into it for extra capacity if you know, there's a spike in traffic for some kind of an app. You know, moving into other regions, right? We're launching a phone. That phone, you know, Firefox OS, emerging markets is a lot of where we're looking to, you know, build that user base. So, you know, South America, Southeast Asia. Building a data center there is you know, potentially expensive. But hey, Amazon's already done that. You know, they've got Singapore, they've got Sydney, they've got Sao Paulo. Why not? You know, we move into them. See how it goes. You know, build into the cloud first. Potentially a year down the road, we might be building a data center because we have enough traffic, enough demand that it is cheaper. But using the cloud, and we're kind of focusing on AWS at first, lets us do that. Some things like S3 we're probably adopting for production. Other things it's potentially experimental. In addition to what IT's doing, our release engineering team has moved a lot of our builds into AWS, into VPCs. The internet there's no way to get to the internet from these VPCs. But we're running hundreds of builds on them, you know, Windows, Linux, all across that. There's been some really interesting blog posts about that and how we've moved a lot of Linux and Windows builds into the cloud dynamically, and then reclaimed hardware for things like OS 10 that you can't run in the cloud, Windows 8, you know, which isn't supported in the cloud because it's not a server OS. So, you know, a lot of interesting things across many different things. One of the things we're also looking at, in addition to, say, you know, building a cluster of EC2 instances, the same way we run a cluster of physical servers, is our PaaS, the DEA, which is the role in Staccato and Cloud Foundry that runs your application containers. there's built-in support in the Staccato product to give it a API key for Amazon, and it will launch additional DEA hosts from an AMI automatically based on certain performance and a number of running container thresholds. So that's something else, right? We have a footprint in the data center, and we're able to, like kind of do that dynamic bursting.
We're getting right into the Q&A.
Yep. So, yeah, that's kind of it. And
I understand all the webheads are physical boxes.
Mhm.
There's no virtual boxes.
Right.
For the webheads themselves, yeah.
How does that tie up into this virtual environment that you're planning on having? How would you scale from going from physical webheads to
So there are a couple ways to do that. I think probably the approach we would take with like web server clusters is treat it like an additional data center, where we would use our sort of DNS, like, DynEC, like the DNS load balancing would then add it as another data center. So we would approach it as like a multi-homing problem rather than like a bunch of other private data centers that we would send across the VPN.
And the key thing too is we're not talking like vanilla Amazon instances. Like these are going to be behind a VPC. We have control of them, really kind of like their internal infrastructure anyway. So treating it like a data center isn't really all that different from it being a data center that we operate.
You have a lot of different tools that you've kind of created and then passed off to developers. Do you spend a lot of time advertising those tools to the developers? Have you had some that have had like really good uptake and some that haven't?
Yeah, like I think we try to make sure that we get in front of our web devs as much as possible, especially when they have, like, we're a really distributed company. So we'll do it as much as we can by kind of talking to the leads in each of the groups to kind of like boil it down to them. We attend some of their offsites, they attend some of our offsites. So we try to share it that way, but we also, like, all the stuff we do is on GitHub. Like it's rare that we have anything that's private. So I think the knowledge transfer amongst all of our groups is really quite high because everything's kind of public and we talk about it openly.
And some of the tool choices have been driven by developers asking them, hey, this Sentry thing is really cool. We'd like to use it. What do you think? We look at it. Yeah, that's great. That totally makes sense. We want to get away from like exceptions being sent by email to 20 people. So yeah, we'll build that and we'll run that for you. Graphite was a similar thing. Like, we started playing with it and then developers heard about it, right? Blogs, Twitter, whatever. And so they come asking and we're like, yeah, we're doing this thing. And other times like Logstash is something where, it's something that we're driving. But there's a mix. And Chief was something one of our guys wrote, but it was, developers and us talking together and saying, hey, like, we want to do this thing. We want to adopt this practice, this workflow. What can we do? Sometimes we adopt a tool. It's very common. Sometimes we build a tool.
And I think that goes to like the idea that we're always looking to improve our processes, right? So we at least Brandon and I can speak for our team. We're not in the business of saying no. So if people come to us with a really compelling thing that they want to do, we're going to say yes because it makes them happy. It's going to make us happy. And it's going to do better for our organization and generally open source because we publish it all.
So what was the name of the NIC that you guys were using?
Miracom.
Miracom. And then as far as like Zeus, is that a legacy thing, or did you use it, test it against Varnish or the other stuff out there, other vendors?
It's been around since before we joined, so I'm not sure what the selection process was for it, but it works, and for the most.
Dimitri, actually, you might know. Do you want to come in?
So, I'm Dimitri. We also tested a bunch of other load balancer solutions, like hardware ones, those from Cisco. I think it's called Cisco.
Ace.
What do you call the name? Ace. Yeah, we tested the Ace LB. We tested also the Citrix solutions. But one of the issues that we had was very important for us, A, to cache the request in RAM, of course, because we needed cache, and B, we need the logs. So the thing is that we have a very big metrics team that they need all the logs from all our websites to be analyzed and to have like our ADU, like active daily users and active daily installations. But the problem was with those other solutions that they didn't track the cache hits. So they only would track what you had in the back. So Zeus does that. So Zeus logs all the cache hits. So this is why we stay with Zeus, because that's one reason.
And it also supports Apache log format, which a lot of the other load balancers, even if they have like a logging through syslog, they don't always support some of the Apache options that we use. You know, we have a large pipeline of things that goes into Hadoop and Postgres that's built around a specific sort of, you know, log ingestion.
And it's also key to remember that even though we still call it Zeus, we're staying up to date with revisions and stuff. So it is Stingray now. We just continue to call it Zeus because everything's just kind of referenced as that.
Is there a particular reason you're splitting between the two CDNs rather than going with one provider?
Because based on, you know, things like Diamond, we've used other services in the past, XDN, FortiGate bot, and then Sodexis. They're different providers are better in certain regions and countries. So by using both and having the sort of DNS load balancing in front of that, we're able to deliver the best POP in a given region.
Yeah, and that's a really good point. Like, it's doing a very critical role. Like, if every one of those downloads all of a sudden went to our own internal infrastructure, we DOS ourselves, and it's happened. So what we make sure that we do in those kind of cases is, you know, definitely having more than one provider is kind of essential. Especially like you saw the kind of throughput I showed just on the Acoma side around our releases. We would be melting equipment if those packets are coming into our infrastructure.
You mentioned a couple of these tools replacing what we affectionately call cron spam emails. What do you use, though, for alerting notification type urgent? Nagios
is what we use for monitoring and alerting for all of our stuff. We're actually fortunate enough, Brendan and I, not to be in the business of doing that. Some of the fine folks in the front row here are. But yeah, we use Nagios for most of it.
Any other questions for Brandon or Chris?
Jordan is one of them.
What was that? Okay.
And one thing on the Nagios, something I mentioned in the Puppet camp talk I did was all our Nagios configs are Puppet driven. So that's you know, something about you can drive like that kind of thing through config management. Something about. Yes.
I was just wondering.
Part of it is we have hardware, a lot of hardware. Like lack of hardware is not a problem that we generally face. So, you know, we're willing to throw hardware at it, and we also have a pretty good relationship with Jordan Sitz, a Logstash author. And so we figure, you know, we can put money into hardware. We want to use it, and also by using it and using it at scale, right, we improve an open source tool that is very much becoming a, you know, must-have tool in your toolkit as a sysadmin and an ops person. So, you know, we would rather sort of put time, effort, and money into it, you know, finding out where it breaks and improving that as an open source thing instead of just licensing, you know, commercial thing. And I won't say that's sort of like the opinion of management. That's a little bit of my feeling on it. We certainly do use commercial things. We use VMware. We use NetApp. Staccato. So, you know, we do take a pragmatic approach to build versus buy, but, you know, in this case, we, you know.
I think the key is there's got to be a really compelling argument to buy, right? Like, if we're gonna fork out a good amount of money, there's got to be something really compelling that it's solving a problem that we really wanted to solve. And between Logstash and Splunk, we were kind of apples and oranges for the way we used it. It doesn't mean that the way your organization uses it is going to be the same, though.
And no one's per se beating down our door about I want a single pane of glass in all my log files. So we have a freedom, right, to work with Logstash and figure it out, and maybe it does, you know, break under load, or it, you know, we're like, oh, it, you know, it has trouble with a certain kind of log file, or it, you know, we need a feature and we have to wait for that to be developed, or we contribute it. You know, there's not like this. It's not like a sort of business driven, like there's a lot of users are like, I wanted it yesterday, you know. It's like a great thing to have. So there's some freedom there to experiment with this, and I think we're going to be very successful.
Hi, I see you all have a lot of self-service stuff for your dev staff that obviously makes them very happy. Have you had any that people ask for and then have just completely flopped?
I can't think of anything. Like the main things we have right now really are Chief and Sentry and
I can think of one. We built on top of Chief Fredo, which has just got really quite complicated. And I think it kind of flopped just because more from our perspective, it became a lot to manage, but it was kind of a post-commit hook that did Chief stuff. So it was like Chief with post-commit hooks, and it just got really quite complex, and we just said, Chief makes the most sense. So that's the only one I can think of off the top of my head, but that was just merely, it wasn't that the developers didn't like it, they loved it, but it was just a really complex system to run, and it was not that well put together.
Yeah, it was designed to allow commits to GitHub to trigger a push into dev instead of the right now dev environments are deployed by cron job every 5, 10, 15 minutes depending on how long the deploy takes. And so but it involved a number of different processes, both RabbitMQ and Redis. It was sort of complicated, and so we sort of said, you know what, we're not going to put this everywhere. Instead, we're going to build you a pass.
Yeah, so the energy went to you've got Chief and the pass.
As kind of a add-on to his question, developers start to create Jenkins plans and environments and stuff. Who cleans up after them?
So right now I'm in the process of cleaning up Jenkins. For the most part, it's just been one HP blade, in one big long Puppet manifest with lots and lots of packages and stuff. And so I'm in the process of overhauling that. Went through disabled jobs that hadn't been successful in the last 30 days. I'm adding build slaves, adding some dedicated, SSD-based blades for Vagrant, sort of taking over that. So for a long time, it was like, it was built, and then it was just kind of like have fun with it, and then eventually it got slow, and so we sort of took ownership of it, and that's what we're doing now. And so I'm, going to beef it up, clean it up, and then add some Nagios checks to watch for, jobs that start failing too long.
But it is a very good question.
So and that's yeah.
We don't have that many of them. Then we'll get it done soon.
But that is a pattern that we've had, as Mozilla's grown, is like, hey, can we have this thing? Yeah, sure, you can have it. And we kind of set it up and kind of, maybe keep an eye on it a little bit, but it's sort of like just run, and it just grows organically and gets busier and busier. And then finally people are like, oh my God, it's critical. And then, we really need you to own it. So then we take it and pull it in. And, some of it has also been IT headcount catching up with company growth. Like I said, we went from 2 to 5 to 7 in about a year.
And our organization's grown a lot in that same amount of time.
Okay, hey, Brandon and Chris, thank you very much for a great talk.